Hi, thank you for your interest and attention in this talk, Design Management for Wicked Problems, towards systemic theories of change through systemic design. My name is Ryan Murphy. My co-author is Dr. Peter Jones. And today we'd like to talk to you about two key contributions, really. The first is to try and recenter the role of design management and design in resolving and making progress on the wicked problems of our time. And the second of those is a way of doing that, which is to propose, we're proposing, a novel technique that combines work and techniques from program evaluation, design, systems thinking, in order to help us understand complex problems and then advance change in spite of that complexity. And so to dive right in, Riddle and Weber in 1973 proposed this concept of wicked problems to try and characterize or qualify the kinds of problems that we're really seeing come to a head now. Things like global pandemics, racism, and other such monstrous problems are what they called wicked problems. And these are problems that, for instance, have no stopping rule. It can be difficult to draw a boundary around the structure of these problems and where they begin and where they end. Wicked problems can also be very difficult to intervene upon because it's difficult to tell if your interventions are making progress, and it can be unethical to test solutions in these kinds of problems. And so Riddle and Weber proposed a variety of other principles. It's highly advised that you go check out that paper if you've never read it. But we just wanted to underscore that concept as what's happening to the world right now, and to emphasize the idea that despite the fact that those problems have been around for a long time, and despite many philanthropists and businesses and other such leaders spending countless resources on trying to resolve them, these problems only seem to get worse. And so we are recentering, or we're arguing, that design and design management can play a central role in making progress on wicked problems. And that's because design is transdisciplinary. It brings together other disciplines in a way that unites them rather than keeping them in parallel. And therefore, it hopefully is able to use those different disciplines in more powerful ways than conventional. It's also action-oriented. Design builds upon implementations and iterations of solutions in order to try and understand them and then reapply those lessons again. It's participatory in bringing together the stakeholders that we need to engage in order to make progress on these problems. And it's dialogic in that we need to have conversations, big ones, with these stakeholders and with each other about the nature and structure of these problems. And it's co-creative in that it asks stakeholders and actors to work together to develop solutions to these kinds of problems. And so this is not a novel call. Many people have actually asked designers to address complex problems in the past, maybe as early, but probably earlier than Richard Buchanan in 1992. But all these other authors and theorists and practitioners have argued that design can play and should play a really key role in making progress on these massive problems. And in particular, in recent times, we've seen the progress or the development of social labs or design labs or change labs where solutions are prototyped in a very design-oriented fashion, tested, worked on with stakeholders, and so on. And so we're seeing a bit of a a development in this scenario, in this arena. But we just want to re-emphasize the role that designers can play in making progress on these problems and propose a new technique to help do that. And so to explain that, we're calling that technique systemic theories of change. This is a technique for design management to use to understand complex problems and to develop strategies that take the system and its systemic behavior into account when designing solutions. So the idea here is, unlike conventional techniques, which tend to reduce the complexity of wicked problems, this technique helps embrace that complexity. By creating models of problems and their causal structure, we hope to allow people to really articulate every aspect of a complex problem and why it persists, and not to reduce that. And we're going to talk a little bit about the kinds of techniques we use to take advantage of that complexity in the development of a solution. And those techniques use analytics and argumentation to help the model talk to us. So if you've got a big complex problem modeled, you've got hundreds of phenomena that are interacting in even more ways, in hundreds and hundreds of ways. We can use these techniques that we're going to talk to you about to actually let the model say or suggest what's important. And in doing so, we identify these key system features, things like potential high leverage points, in order to use those features to develop systemic strategies. So this technique combines two key techniques from other disciplines. The first is theory of change. This comes from program evaluation, and a theory of change helps describe the logic of a change initiative. When you are addressing a problem like poverty, a theory of change helps break down the potential, the impact you want to have reducing poverty in an area, and it steps back from that towards describing the second order effects that can help address poverty, and then the kinds of symptoms that you want to address with the programming that you can do, and then the interventions that you're going to do, the programming itself that addresses these chains of causal structures. So I did a terrible job of explaining that, but it looks like this down here on the bottom of the screen. Theory of change helps you articulate this structure, this logical structure of change initiative, helps capture the assumptions and expectations you have of these initiatives, and it represents your analysis of the situation. And in other words, a theory of change is a really useful technique in order to be able to monitor and evaluate whether or not a program is working. We're also going to use a technique called causal loop diagrams, or a type of diagram called causal loop diagrams. And this is a model of systemic behavior. It helps you explicitly describe the relationships between different phenomena in a system and how they interact. And so you get these structures that are nodes with connections, showing that an increase in A will actually reduce B. That's this negative relationship here. And it also captures things like feedback loops. This feedback loop here shows that A and B keep each other balanced and in check. And so causal loop diagrams are a really powerful way of modeling the dynamic behavior of a system and then trying to understand why these systems can be so counterintuitive sometimes. But there are some issues with both of these techniques. While they both model causal structure, theories of change are often criticized for being too simple. They are victims, or they cause the kind of reduction that I talked about earlier in oversimplifying what's happening in a system. And at the same time, a causal loop diagram is not that useful because it can be too complex. It's hard to know where to begin or end in a causal loop diagram in order to develop an intervention. And so these two problems are kind of on opposite poles, or these two techniques are on opposite poles of being useful in the development of a systemic strategy. And so what we're proposing is called a systemic theory of change, but there have been other authors who've worked on this before. Conventional practitioners using theories of change do understand that this can be a reductive technique, and so they argue that you need to appreciate the complexity of the situations in which you're using to develop the theory of change, and then you're using to monitor the theory of change and the effectiveness of the intervention. Other authors have proposed ways of using them in tandem. Alford, in 3 articles in 2017, showed ways of letting a theory of change inform a systems diagram, a causal loop diagram, and vice versa. And then Abercrombie, Boswell, and Thomasu have provided guidelines for using systems thinking in theories of change. But nobody has quite brought together theories of change and causal loop diagrams holistically. And that's what we're proposing here. So the goal is to actually use causal loop diagrams as theories of change, and we're going to show you how. But first, we actually need to talk you through one more foundational element, and that is this idea of leverage analysis. So causal loop diagrams are actually mathematical graphs. They consist of nodes with connections to other nodes. And because they're a graph, we can actually use theory or analytics from graph theory, such as those used in social network analysis, to understand the structure of the model, no matter how big and complex it is, and to surface the more important elements of the model. Different graph theory algorithms exist that reveal different features. For instance, eigenvector analysis shows the most well-connected phenomena that are connected to the most well-connected phenomena. In other words, those are candidates for what we call leverage points, places in the system where a little bit of effort yields more results. And so leverage analysis is that technique that we use that lets the model talk to us. And so we're going to show you how we use this in a second in a demonstration. But the last thing to note is that while the systems themselves can be as complex as possible, the process for developing these things doesn't need to be. the first step here is to model the system as a causal loop diagram. And once you have your phenomena mapped out and the relationships between them, the causal relationships between them modeled, you then use these techniques that we've proposed in a previous publication in order to highlight these key system features and to let the model tell you what might be important. And then that's where the argumentation part fits in. It's at that point that you as a designer and your stakeholders need to look at the results of leverage analysis and interrogate it. It might reveal that something seems off about the model, and you might want to go back and add a little bit of detail. But you can still let the leverage analysis ultimately tell you what might be more important or less important in the system. And then finally, when you have these system features, and we're going to show you what this looks like in a second, you build a theory of change from the model, and you use these features and the systemic structures like feedback loops in the theory of change that you've developed. So, for a quick demonstration, here's what a causal loop diagram looks like. This is a model of entrepreneurship in Canada and the kinds of systems phenomena that can support or facilitate entrepreneurs starting startups in Canada. And as you can see, even though it's not that complex, there's maybe 40 elements in this model, it is too complex to look at it and know what to do with it. And so this is a really good example of how even a little bit of complexity can make it an insurmountable thing for our minds to be able to process all at once and to use strategically. But when we run leverage analysis, we get a few interesting phenomena or a few interesting features that we can then use in developing strategies. And so I'm going to do a time check, sorry. So the first of these is the identification of a goal. And a goal we simply identify manually. We look at the map and the phenomena that we're looking to encourage, and we select one of those phenomena or several of them in order to target our interventions. So our goal here is facilitating entrepreneurship and encouraging more entrepreneurs to start up companies in Canada. What leverage analysis also surfaces is these potential high access points. These are phenomena that are sort of on the edge of the system that might be easier to intervene upon. And so those are potential points in which interventions might have a little bit more power. The second thing, or third thing, that we surface with leverage analysis is leverage itself. These are the phenomena with the green flags or teal flags here. And those are developed with the eigenvector metrics that I talked about before. A fourth is barriers. Those are the purple flags. And so these are phenomena that happen to sit between other phenomena the most, and therefore they might be barriers or bottlenecks as change propagates throughout the system. And then the final thing that we've highlighted are signals. And these are the blue flags, and they're the places in the system in which there might be an indicator that change is happening if these phenomena, the signal phenomena, are moving up or down at all. And so with that, it becomes pretty easy to actually take the access points, the yellow fringed circles here, and draw a path from these to the goal of entrepreneurship. And so that's what we've done with these two examples. In the first one, we're taking advantage of those right-hand side elements that focus on the role of teachers and parents in educating entrepreneurs. And we're suggesting that a school-based entrepreneurship incubator might actually play a really neat role in helping teachers and students create a better mindset for efficacy, for problem finding and problem solving. And that, we're suggesting, reduces fear of risk according to the model that we used, which should enable entrepreneurship. And then this theory of change, this systemic theory of change, also takes into account that systemic structure that I talked about before. Because the more entrepreneurship's enabled, the more activity will happen, or entrepreneurial activity and events and groups will happen, which supports entrepreneurial culture, which should also facilitate the development of more and more of an efficacy mindset, especially in youth. So that's one example. This second example targets some of the barriers that we identified in the model using leverage analysis. In particular, the idea that access to investment is a key barrier in the growth of this system. And so we're proposing that a national investment matching program will help domestic investors have more impact with their money. And so we're targeting this access point of domestic investors to deal with this barrier of access to investment. And that leads to this feedback loop encouraging entrepreneurial growth in the system, which leads to more successful scaled businesses, which leads to more entrepreneurship. So that's just another example. Ultimately, hopefully you can see how these systems-informed strategies might be more useful in addressing these complex problems, and that also they help monitor and evaluation because you can see the lead and lag measures in the system that you're trying to address. There are some limitations here, but for the sake of time, I'm going to move on. Hopefully you see that design management should play a key role, and that systemic theories of change really help to generate better approaches, or could help to generate better approaches for making progress on these problems. Thank you.